Hello, and welcome to today's Tuesday webinar. My name is Eva Leos, and I will be your host. We will be joined by Dexter Lilly and John Arzinski, who will be giving us insights into augmented reality and the positive performance results of implementation. We will answer questions at the conclusion of this session, so feel free to type them into the question box throughout the presentation. I would like to introduce our speakers. Dexter Lilly is the Executive Vice President and CEO of Index AR Solutions, and he has extensive executive experience in the shipbuilding industry. He's an agent of change who has been instrumental in ushering in lean manufacturing techniques to drive significant improvements on labor costs, and by using modern scheduling techniques to dramatically improve schedule performance. Also, we have John Arzinski. He is the Director of Operations at Index AR Solutions. He has worked at Bank of America, Northern Grumman, and Huntington Ingalls Shipbuilding. He is an economic guru and has advised many on asset management. Please welcome John and Dexter.
Eva, thank you so much for that glowing introduction. We have a fairly simple agenda today, but I hope we are able to get across a lot of information in a very short amount of time. Simple agenda: what is augmented reality? I'm going to speak to that for a few minutes. Then we're going to talk about the uses and value of AR, and then implementing AR, and we'll wrap up with conclusions and then questions. So before I jump into what is AR and how it works, one thing I would like to do is talk to you about why AR. As Eva mentioned, my background is in construction and manufacturing in the shipbuilding industry, and my team and I were able to bring in lean manufacturing into that construction and manufacturing environment back in the late 90s, and really got that lean working well in the early 2000s. What we saw with that implementation was reductions in cost and schedule in the 10–15% range, and significant engagement by the workers there, and a lot of non-value added work that was eliminated. Since lean, I have not seen anything come along, and even with lean in the last 20 to 30 years, that I think is going to have the impact that augmented reality is going to have. So this theme, I would like you to have this theme in the back of your mind, that augmented reality properly implemented eliminates or significantly reduces non-value added work. And I'm not talking about 10 or 15%. I'm talking about 30 and 40 and 50% reductions in cost and schedule. We're seeing that in practice. So I know a lot of you out there are technologically savvy about augmented reality, but I know there might be a few on the line that aren't, so I want to start with the basics. Augmented reality is the overlay of digital information on the real world or reality. A common example of that is the first down line in a football game. The yellow line is there to tell you where the next first down is, but the folks in the stadium do not see that when they're there. So that, similarly, there's a line when you see, we've got the Olympics coming up this summer, probably in a couple of weeks, we'll see some swimming events, and that line is showing where the world record is and the time. So all that augmentation is there to help the viewer, provides more value and more information to the viewer than you would see while you were there in the stadium. So it's augmentation that helps the person that's actually doing the viewing, and in the workplace, the person that's doing the work, or the technician that's doing the work. So how does augmented reality work? There are four major pieces to this. First of all, you need a powerful mobile device. And back in the mid-2000s, the advent of the smart mobile phone came about, and shortly thereafter, smart tablets. It wasn't until about the around 2011, 2012, that those devices became powerful enough to allow for augmentation using those mobile devices. In more recent years, head-mounted displays, and we'll talk a little bit more about this, also became powerful enough to allow you to do augmentation out in the workplace and out in the field. In addition, within those smart devices and the head-mounted displays, you have to have a camera to allow you to see reality and have that reality show up on a screen, which then allows you to do the augmentation on top of that screen. The third component of augmented reality is the data itself, the digital data. Many companies have just a plethora of data in the form of 3D models, in the form of videos, text, audio, even audio information, and in most cases they're not leveraging this data to the fullest. And I'll talk a little bit more about that later, how augmented reality allows you to leverage that investment that you've already made in your digital data and extract more value out of that data. And then finally, on the software side, you need two major pieces of software. First off, you need computer vision. Computer vision does basically three major things. It establishes pose. And for those of you that aren't familiar with pose, it's the three-axis orientation of the device in your hands, if that's a tablet or smartphone, or the head-mounted display on your head. It also allows you to acquire and track an index or target or actual physical objects themselves. And then finally, last but not least, you need authoring software. Authoring software is the software that allows you to create augmented reality solutions. We at Index have tried every major piece of augmented reality software, and it has some value for certain situations and certain challenges and certain however, what we have found that it's not robust enough to solve the complex heavy industrial problems and challenges that we have seen in our environment that we've come from at Newport News Shipbuilding. And so over the last 4 to 5 years, we had to create our own software for doing that. Next, I'm going to switch gears a little bit, because as we've gone out and talked to people, we've talked to probably a couple hundred people and talked to 50 to 100 different companies. One of the things that we constantly are faced with is the confusion and misunderstanding between what is AR, augmented reality, and what is VR, virtual reality. So I'm going to spend a little bit of time on this slide. Augmented reality, and I'll go line by line, by definition is the overlay of digital information on the real world. With VR, you immerse a person into a virtual world, a world that's completely manufactured. Users on the AR side interact not just with the physical world, but with virtual objects that are overlaid over top of that physical world, but all in the natural environment or in the site or in the location or in the plant or factory that they're located within. On the virtual side, your interaction is with virtual objects in that manufactured or created virtual world. Again, on the examples of American football, first down line is a good example. I talked about that. On the VR side, some of you may have experienced a product model environment where you sit in a room with a screen and you put on 3D glasses, and it allows you to enter that virtual world of the product model itself and kind of walk through the product model. So it's still an artificial world because you're not in the real world. You have those 3D glasses on and you're looking at that screen. Hardware, AR, smartphones and tablets that are available off the shelf can create augmented reality. And also there are at least 15 to 20 manufacturers of glasses today, and we'll talk a little bit more about the glasses in a moment. On the VR side, everybody's heard about Oculus Rift and some of the other VR glasses that are just coming out. And those typically are enclosed. There are some things like caves that people can walk into and do VR, or as I mentioned before in the example, where you have a screen and you have 3D glasses on and you can sort of enter that virtual world. On the use side, we see AR as really valuable in construction, manufacturing, maintenance, training, and industrial marketing. I'd be remiss if I didn't mention that there are some games that can be played with AR. You can download and play AR zombies on your iPhone or your Samsung or any Android device today. But I don't think, in my opinion, AR is not known for games. It's more known for what it can do in practical application. VR games seems to be the very big thing with virtual reality. That's everything. That's a lot of what's on Oculus Rift is games. There are some experiences too, where you can experience the video feeds from what other people have done in 3D. It is good for design collaboration, where you might have designers that are located in different parts of the world, and they could put on their VR glasses and be able to collaborate on the design process. It's also very, very good in training when the situation is that you do not have a physical product yet. So you're in the design stage, or you're in the early stages of engineering and designing a product or a plant or a piece of equipment, and you want to train somebody on how to use that, then you can create this virtual training environment and allow people to train on that. So it is excellent in that mode. Once you have the physical object and that's in effect, or you even have a mock-up or a 3D model of the physical object, then we would suggest moving away from the VR and applying AR in that training situation. So let me take a minute and talk about head-mounted displays. Our company's done over 50 projects. We spent 5.5 years in research and development on this, and we've done over 50 projects. We believe that 80 to 90% of the value of augmented reality can be had today using tablets and smartphones versus head-mounted displays. Today, we've tried every head-mounted display that is made out there. We've had them on our heads. Me personally, most of them. Our team, all of them. What we're finding today is they're delicate, expensive. They can be somewhat distracting. Your field of view constraint, and we're really not sure about the long-term health issues. That being said, we believe that in 18 months to 24 months, there will be a set of head-mounted displays that comes out that is ready for this heavy industrial use. There are use cases today that could benefit from the head-mounted displays that are out there. We do believe that what's going to happen as you go forward in the future is that the use cases are going to divide, and that some use cases will be best suited for tablets and smart mobile devices, smartphones. Other use cases will be better for head-mounted displays. We don't think it's like you got to use this for every case and you have to use this for every case. There's going to be situations where each set of devices is really specific to that use case. They have to understand, what you're getting yourself into, and that there's a decision point there to make in terms of the use case. Our suggestion to the audience here is that don't wait for the right head-mounted display. You may select incorrectly, you may select too early, you may decide to switch later to some other head-mounted display. So don't wait for that. Go ahead and get into augmented reality with a tablet. Even experimentation with early head-mounted displays is fine. Make sure that whatever you do there with your solutions that are being created either by your own company or by another company, that you're able to migrate those solutions over to head-mounted displays. That's what we do, but I suggest to anybody that does that, you have to do it the same way. With that, I'm going to turn it over now to John, who's going to talk about the uses and value of AR.
Thank you, Dexter. In the following slides, I will be discussing what are the best AR use cases, a few examples of these, and some metrics related to these, a life cycle view and how that relates to augmented reality, as well as how the trades view augmented reality. On this slide, we will see the 7 use cases relative to technical readiness. On the first row, we have inspection, work instructions, and training. Of the 7 use cases, these are the most technically mature, and we're seeing great results when these are deployed in the field. On the next row, we have workflow management, operations, and safety. Slightly less technically mature, however, we can achieve great results when implemented. And on the final row, we have logistics, the least mature technically, however, also a great use case. When it comes to augmented reality and training, we are seeing roughly a 50% reduction in the time for training. Now, this means less time training, as well as less time for the workers off the job. This picture to the right, what you're seeing here is an AR solution developed for the U.S. Navy, and is a training solution for a governor for a large diesel engine. The diesel engine is roughly the size of a room. And using augmented reality overlays, the solution shows startup, install, and removal with an overlay of step-by-step instructions. It actually even shows internal component movements so the individual can really get a feel of what's going on inside the device. While going through the procedure, the solution even has sounds that match the reality of the device. All this can be done on the actual governor or a 3D printed version of it. Now, AR for training eliminates the non-value added need to go through the paper training manuals, and it allows the individual to simulate on-the-job training on the actual object. Now, this solution, the Navy customer actually, they love it, and they plan to actually implement it across all governor training procedures. Let's discuss augmented reality work instructions. On our third project out of over 50, we performed work instructions on a large structural component with roughly 1,000 welds and reduced direct labor and schedule by 35%, with a 40% reduction in non-recurring engineering. There was also 0 quality escapes. The experienced worker who was performing this work had completed it roughly 13 times before, and the learning curve had flattened out. The solution eliminated the need to look up the drawings that referenced the welds. Now, it's important to note that this was our third project, and it was a precursor to our modern AR solutions, but we even achieved these incredible results with this. Work instructions actually can include step-by-step instructions using 2D overlays, text, audio, video, 3D animations, and they can be as few as 4 to 5 steps and as great as 50 non-sequential steps. In other words, you could perform steps 1 through 5. Material is missing for step 6, so jump to steps 10, 11, and 12. But then you must finish steps 6 through 9 before you can go to step 13. We're seeing some of our best results using augmented reality for inspection, though we're seeing incredible results, as you can see in the previous slides. We recently completed an inspection for a multi-billion-dollar asset, and it was a survey that was in the critical path, and the survey was scheduled to take roughly 6 weeks. With an AR solution, we reduced that survey time from roughly 6 weeks to 3 weeks. I'm going to pose a question here. How much would it be worth to you, to your company, or to your clients to reduce a survey in the critical path from 6 to 3 weeks? The next example of a inspection was actually an inspection for temporary steel. And on ships, oftentimes there must be temporary steel installed to help bring in equipment, large pieces of equipment into the ships. And a 40-year shipbuilding veteran used an AR solution developed by our team to perform what was previously 36 hours worth of work, and he did it in 90 minutes, the first time using the solution. This was a 95% reduction in cost and schedule. Now, the inspector did not have to reference drawings, and he did not have to locate himself in the space. Locating himself in the space relative to the steel was very difficult for this inspection because the steel is blasted and painted, and it looks like the rest of the structure of the ship that should be there. And because of the AR solution, he was able to quickly identify what steel needed to be taken out and schedule it for removal. In the previous slides, we discussed how the augmented reality use cases are. Now, on this slide, we are going to discuss the project lifecycle and how AR can be applied throughout it. AR can be applied throughout the project lifecycle from marketing through decommissioning. For example, work instructions can fit into manufacturing, construction, operations, maintenance, and decommissioning.
In fact, John, I think a good example of that is in maintenance. If you had a complex startup or shutdown of a major piece of equipment, either your own equipment or something you were providing, or a plant that you were providing to a client, you could create animated step-by-step solution that a new employee would get very quickly and could run through the steps, and it's clearly showing the person how to take each of those steps, what tool to pick up, which way to turn the screw, which way to flip the switch, so that they don't miss a single step. For the experienced employee, it helps prevent them, over time as you learn to do things, you tend to skip over things. It helps prevent them from skipping over a step as an experienced user. So that's just one example of a work instructions accomplished in maintenance. You could do that almost with every single major step in this life cycle.
In addition, training, safety, and quality can run throughout the life cycle as opportunities for AR arise. And now think back to the 7 AR use cases, and most of these use cases can be applied at each of these points along this life cycle. Another important perspective to think of when referring to augmented reality is, how do the trades view AR? Now think back to those 7 AR use cases. Every trade can benefit from augmented reality in some way. Now the feedback we're actually getting from trades is that they love our AR solutions. It makes their jobs easier and allows them to perform the work they have been trained to do. It eliminates the non-value added work such as reading the drawings and measuring. It's also important to note we're seeing no demographic limitations for augmented reality. Everyone, regardless of their age, their language, or educational background, rapidly learns how to use these AR solutions. It's due to the visual nature of them. I'm going to turn it back over to Dexter so he can discuss implementing augmented reality.
So I'm going to take a few minutes now and talk about some key enablers and a few obstacles to implementing AR. I'll then talk about what we think are the appropriate steps to take to implement augmented reality in your company, and then finally I'll talk a little bit about the benefits and a kind of a broader look at those versus the specific examples that John just gave you. So I want to spend a little bit of time on this chart because I think it's really important. In the key enablers and obstacles. AR is ready now. It's not something that you have to wait to do. It is ready and available now with off-the-shelf tablets, either iOS or Android or Windows tablets. The technology is there. There are people that have the capabilities, the experience, and the knowledge to tackle complex industrial problems and solve those today. What's not well understood is not necessarily the technical piece of this. I know there's a lot of people that really understand how AR works. There are some people listening in today that have no doubt understand this from a technical nature, maybe even better than I do. I suspect there's a few folks on our team that are some of the best in the world, and maybe you can't stump those guys, but you might stump me on the technical side. However, on the application side, on the use case side, that's what's not well understood, because people see AR and they think it's simple, but they don't see it in terms of how it's applied in complex industrial environments. That's where it takes a lot of expertise, a lot of knowledge, and a lot of experience to really understand industrial problems, understand where AR is best applied, and then be able to develop solutions that work. And so that's the piece that when I say it's not well understood is what I mean. And it's an obstacle because people see it and they see the simple side of AR, but they don't see the complex side of it. And they think it's all simple, and it's not. It's easy to train end users. Here at Index, we have a goal of 10 minutes. Once we go in, understand a process, understand the challenges within that process, the data requirements, and then we go back and create a solution. When we hand it to the person that's going to use it, whether it be a quality inspector, a worker down on the job, when we hand it to that user, our expectations is that they learn how to use that in 10 minutes of us talking to them. If they don't, we don't think we've done our jobs very well. It should be intuitive and easy to use. And again, it's not easy to create. It takes a village to do this. We have engineers, designers, software developers, graphic artists, and even human factors engineers on our team to allow us to create the type of solutions to complex industrial challenges that exist in the construction environment that I certainly came from, and the environment that many of you listening in today are in. Company data is in place. I mentioned this before when we were talking about how AR works. Well, companies have a ton of data that is available there today that they're not really leveraging and extracting. You can see on the obstacle side, there's a lack of experiences to how to take that data and leverage it to extract more value out of it. And augmented reality, properly applied, allows you to do that. You can extract more value out of that investment you've made in your 3D CAD models, and and get a whole lot more value out of that by taking that 3D information, taking those videos, and taking those all of that information you have in digital form and putting it in the hands of the worker and the technician. Another enabler is ubiquitous smart mobile devices. We mentioned this before, started back in the early 2000s, but really 2011-12 started getting powerful enough to allow us to do augmented reality in the field, on-site with smart mobile devices. We have seen as we've gone out and talked to folks that there's a lot of, there's a tendency for some people to want to wait and see. They want to wait, they have this wait and see attitude. I'll just wait until the, you know, all the 20 or so vendors of head-mounted displays until kind of that plays out, until the 2 or 3 right ones come out. That could be 2, 3, 4, 5 years from now. We think that's a mistake. We think you need to get into it now, use whatever's available now. You can use off-the-shelf smart tablets and smartphones, and then if you want to migrate to head-mounted displays later, that you can do that. But don't wait. Don't wait to learn and understand and test this out yourself, or work with somebody else to test this out in your company. We're seeing the emergence of industry trailblazers. Our teaming partner, Newport News Shipbuilding, we consider one of those trailblazers. They've been doing this for 4 to 5 years. Just for sake of transparency, we have a teaming agreement with them, and we utilize their engineers and designers and all of their entire AR team of 30+ people to go out and apply this out in the industrial world to outside companies. But they are trailblazers. We don't think they have an equal in the industrial world. They are changing processes permanently today with augmented reality. Prior to the last year or so, they were doing pilots and projects that were one-offs, but they are, over the last year and today, they are putting things in place that allow them to permanently change processes with AR. One of the problems we see and obstacles we see is that some of these trailblazers are reluctant to share results. It provides the companies with such a competitive advantage that they don't want to share how they're getting there. And frankly, I don't blame them. If I am one of those companies, I might be there myself. But hopefully over time, some of that information and shared results will come out, which will help others get on board. Okay, I'm going to switch gears a little bit. I'm going to talk about how we believe that companies will adopt AR. What you're looking at right now is an AR S-curve for adopting technology. And I won't spend a lot of time on this slide. Suffice it to say that almost every new technology follows this S-curve, and some are slightly longer and shorter, which you can see that as you progress into the 90s, late 80s and 90s, that becomes, the S-curve becomes steeper and steeper with the internet, cell phones, computers, and the like. We believe that this is going to be the same type of adoption curve that we have with augmented reality, that people will begin to experiment with prototypes, proofs, and pilots, and that would be at the low end. But there is a significant difference here with augmented reality. Unlike a lot of technologies, you don't need a large upfront investment to experiment with AR and prove the technology to both yourself and your company executives. You can do those prototypes and proofs and pilots and measure the results, measure the investment, extrapolate over a larger population, and prove to your executives that you want to move to the next level, which is to do larger projects that have more significant results. And then finally move into that program and production phase in which you begin to apply this to a broader set of processes and products. You can see the immediate results with small prototypes and proofs and pilots today, but that again, we see that adoption curve. One of the things you're going to see is that there's no timeline along the bottom here. And the reason for that is we believe that there's, like almost everything, every company's different. We believe there's first movers who are very aggressive and innovative, and those of you out there will know who you are and where you fit in these categories. Those people will gain a competitive advantage by being first. They will learn this technology. They will learn where to apply it. It works across a broad set of stages in the life cycle. It works across a broad set of trades, as John mentioned. Those first movers will make this happen in 2 to 3 years. They'll move out of the product, the proofs and pilot stage, into products and into programs very rapidly. The followers will want to see more results. That will slowly come out in publications over time. People will begin to feel more comfortable about producing their results, and the followers will probably take 4 to 5 years to get through this. Our analysis, our perspective is that. Finally, you have the stragglers and what we call the lost. They'll take the longest. They'll take 6 or 7 years, or maybe never, to get through this. And the reason I say the lost they'll never get through this is by the time they get it implemented, we believe that the advantages made by their competitors will either make them significantly lose their business or put them out of business. That's how large and that's how big we think augmented reality is going to be in this construction and heavy manufacturing environment. It's going to drastically change the complexity of it's going to drastically change the landscape. So let me talk about the benefits for a bit. For those of you that have been exposed to lean manufacturing, this will not look unfamiliar. It's something we call a process ladder. It's very general in structure, but it shows the current process and then the process after we've implemented AR. And like every process, it has a series of steps. In some cases, there are steps in a process that AR does not, it's not the right tool. It's just like any tool. You have to have knowledge and understanding and experts in where to apply AR and where not to apply AR. So for instance, in step B, there's no improvement because there was a decision made that this step will not benefit from AR. Step E, a slight improvement from applying some AR. Steps A and C, a fairly significant improvement. So in a lot of cases, the things that we're seeing, like these type of steps, we can see 30, 40, 50% improvement cost schedule with improved quality. And then finally, step D, we're seeing this over and over again as well, where you have a total elimination of a process, because what happens, I think over time, we've done this for so many years. We've read drawings for so many years that we think that it's part of the process and that it's value added. This is not value added. It does not make the product get built. People make the product get built. Augmented reality improves the capability and capacity of people by putting information in their hands where they need it and when it's needed in a form that's easily understood. So that's the difference. We're replacing that drawing or work package with a different way of viewing this. And you can think of augmented reality as a new communication tool. So that's how it helps eliminate. And we've seen drawings eliminated, we've seen work package eliminated, we've seen measuring eliminated, we've seen hunting for materials eliminated with augmented reality. And of course, that gives you that significant benefit that we keep talking about in the overall process. If you look on the benefits achieved, again, this is a manageable, small upfront investment for a long-term, large return. And it reduces the big three, improves the big three: cost, schedule, quality. It also enriches knowledge transfer, and it does this in two ways. It transfers knowledge from older, I shouldn't say older, more experienced workers and technicians to those that are just starting in a field. It also transfers knowledge from those who plan and design how a product gets built, the engineers and planners today, to those that have to go build that product in such a way as to make it more intuitive and easier to understand what the message is being sent. And finally, customer experience. You can see this in two ways, enhance customer experience. One, augmented reality can go as part of a product you deliver to a client. So it can be in the form of maintenance manuals, operation manuals. Those can all be augmented instead of paper documents. And then also kind of at the opposite end of the life cycle in the marketing phase, industrial marketing can also enhance your ability to communicate how things will work and how things will look to your clients, so their customer experience becomes enriched. So let me conclude with a few statements here. Key takeaways. So augmented reality is providing positive results today. We've seen that over and over again. Cost, schedule, quality, all have been improved. We're seeing benefits throughout the life cycle. I know John talked about this a bit, but we've seen it in construction, we've seen it in manufacturing. Just every phase of product life cycle, there are ways to do this. And then again, John mentioned training. Training goes throughout. Not all of the use cases go throughout, but most of them do. And then in training, work instructions, inspection, all of those things are providing benefits in the product life cycle. Again, it's ready now. It's not something you have to wait for. The hardware there is there. There are people out there with experience, expertise, and knowledge that can help you with this. You can try to do this on your own. That's going to take you some years to get to where some of the other folks are. It is easy to use, and it'll continue to be easy to use if properly created by the people that are authoring the augmented reality solutions. It becomes easy to use by the people using it. But again, difficult to create for complex industrial challenges. First movers, we sincerely believe that they'll gain a competitive advantage because of the significance of augmented reality and what we're seeing on many processes on many levels, that first movers are going to gain a competitive advantage and other people will be playing catch up. And finally, we continue to believe that waiting for the right hardware is a mistake. Start today with your off-the-shelf products. Experiment with current head-mounted displays, but don't wait for the perfect head-mounted display to come on. Start today. There are ways to do that, many ways to do that with the hardware and software and teams of people that can help you along the way today. So finally, to close this out, early adopters are seeing significant positive results today. We've seen that over and over again, and we expect to continue to see that over the next couple of years. With that, if you have any questions, we're very open to that, and if you need some additional information, you can visit our website or our YouTube channel. We've got those up on the screen. And then we've got John and my contact information there as well. We're very open to questions from you.
Thank you so much,
any questions?
So there's a few questions, and the first question is, AR is easy to use, but it's hard to create. You had some aspects where you elaborated on that, but could you go into any extra details that maybe got missed?
Yeah, yes. Yeah, I think there's this kind of misinformation out there about it's easy to create, because we've seen cases where it's pretty easy to take the cover of a magazine and attach a video to it, or it's pretty easy to take something and attach it. But the difficult part is having the industrial background and the augmented reality expertise, and being able to put those two things together to solve complex industrial problems. That's the piece that everyone seems to miss, and it's not a one-week process. It takes sometimes a month or 2 months or 3 months to tackle a tough industrial problem and be able to solve that with a team of people. You just can't go buy a piece of software. You can go buy a piece of software, but I guarantee you, you cannot go solve a problem like that in a week or two.
Okay. Can you define what mixed reality is?
Yes, I can. Think about that for 1 second. Mixed reality is
mixed reality is the interaction with both the virtual and physical world.
Yeah.
So you actually could have physical objects in that environment that are interacting with the augmentations or the virtual.
Okay. Yeah, sometimes I think those definitions are...
They're changing a lot. They're very dynamic.
They seem to be dynamic. I like to stick with AR and VR because Wired Magazine wrote a definition of those recently, and to me there wasn't a lot of difference in the definition between AR and mixed reality.
Okay. So when it comes to the case studies that you presented, how do you include the human factor into designing scenarios in which AR or VR would help support the activity, the training, and those processes?
Well, I'm trying to make sure we understand the question when we say the human factor. What our experience, and I'm going to say something here. I'm not sure it's answering the question precisely, but what our experience has told us is that the people that use AR love using it. We haven't run into a situation where somebody says, I don't like using this. We're able to design it in such a way using, we have human factors engineers that help us understand what comes across and is intuitive to people and how things should look and feel so that they'll feel very comfortable using it. Something like 3.5 billion people have smartphones today. So they're used to using smartphones to access data. And we want to make our applications feel just as comfortable to them as using their smartphone. Hopefully
yeah, I think that
question.
Makes sense. Yes,
okay.
I think it would. Okay, so in a world where buzzwords and acronyms are all the rage, how do you keep the term AR essentially from becoming a buzzword as BIM has become in some industries?
Well, I think it is a little bit of a buzzword. Mm-hmm. I think what's going to happen is over time, as people begin to learn and understand and read about what it can do, what it can't do, and the results that it can get, I think that'll just fade away over time. It is a little bit of a buzzword today. Okay. But that's okay. That's okay.
So,
John,
how does AR, sorry about that, go ahead, John.
Oh, no, it's okay.
How does AR improve knowledge transfer?
That's really a great question. Because here's a key factor that people need to understand, is that augmented reality is a new communication medium. It's not just, it's not just putting something that appears, it's not just overlaying. It's a new communication medium. It's a way to move knowledge out of the brains of the engineers and planners that design and engineer products and processes and plan how those get implemented into the hands of the people that have to do it, do the work to create that. And it does it in a new way. I mean, you almost have to put it in the same category as television when it first came out, or movies, or telephones. I mean, when movies first came out, people really didn't understand how you could make a photograph turn into things that moved on the screen. This is the same thing. It's allowing information to move from one person's brain to another in a new and very, very intuitive manner. So that's how it happens. Now, it takes work to make that happen. It takes work to take what we used to use, a piece of paper, and read a set of instructions, and then have to translate that written word into some visual information. We're bypassing that written word. We're using those engineers and planners in a much different way to create that experience that is so intuitive to the worker or technician that allows them to learn much faster and move that knowledge, take that knowledge and absorb it much faster. I mean, we naturally learn in 3D, and we have not had a methodology that allows us to transfer knowledge in 3D until now with augmented reality. Does that make sense?
I think it does. I think that this new aspect of learning is making sense. Now, as people are beginning to introduce this into their process, would you say that a good Revit model or a laser scan of a building is a good start of AR, or is that not quite yet AR?
Well, let me say this about that. First of all, I'm not the technology expert in our group. I'm one of the business managers here. But I know enough to be dangerous. But here's our experience. Our experience is there's no CAD model format that we cannot translate into augmented reality. In some cases, we have to do some work to make that happen. There was a second part to your question.
It was laser scanner.
Yeah, laser scanner can be used, but there's a lot of data there in this 3D. Sometimes the 3D aspects of laser scanner doesn't come across correctly. So there's actually there's too many data points when you do laser scan. So you have to take some data out, and sometimes the 3D is not quite where it should be. So it's best to start with AR. It's best to start with the 3D models that's been designed from the design up. But you can use laser scanner or other scanning technologies. Now there are some things coming around the corner here, and we've played with a lot of these, like Tango, Google Tango, Microsoft HoloLens actually will do this. They'll actually map the space themselves and begin to create a map of the space that you could then translate into some augmentation.
Okay. So the next question is a little bit more associated with wearables and security. In a world where we are now transitioning wearables with Wi-Fi and Bluetooth-enabled devices, have you seen challenges that, as they relate to security, that companies are addressing or that companies bring up when you all are interacting with them?
Yes, a lot of companies, they don't want their data in the cloud. They want secure data. They want data integrity, data security. They want everything inside of their own sort of in their own bubble of information bubble, so they can protect it. So yes, we've seen that. There are ways to do that. There are ways to create private protected clouds. I mean, Samsung has Knox that you can protect things inside of on Android devices. Companies are very they're very concerned about that. So they don't want just data floating around just on public Wi-Fi or any. They want everything on their own private networks, and that's not that difficult to do. We can do that. We can create apps that they can download. We can cycle data back and forth on their own private protected Wi-Fi networks.
Excellent. So here's an interesting question. If a department were to staff AR development team and they were actively looking to bring in the newest, youngest talents such as college grads, doctors, PhDs, what would be the best type of college grad that could lend to a design team develop an AR department?
Yeah, John might have to help me with this one, but I don't think that there's anybody providing a degree in augmented reality today. There may be some people at the PhD level specializing in augmented reality today. I don't know. Do you have anything to add to that, John?
I think on this question, I'll talk about our experience, and over time, I'm sure universities will start supplying individuals that fit into these skills. But our experience is we actually home grow a lot of our AR teams. So we'll at our teaming partner at Newport News Shipbuilding, for example, we'll have an engineering, maybe a mechanical engineer, and he or she may be a mechanical engineer, and that individual will go through a AR training program that has been developed there, and they will become an AR engineer. And what's actually really valuable about this situation is that that individual has experience in manufacturing and construction in a different setting, and they're able to bring that into their to that augmented reality team. So it's actually a very valuable thing, and so we've had to develop that training curriculum so that we could field those individuals.
Yeah, that training took multiple man years to develop, and
okay.
It allows us to now take somebody and over a period of months kind of create an AR engineer or designer or developer.
That makes sense.
But yeah, it maybe not fully answered your question there because we're not, at least, it has to be an engineer, but at this point I don't think there's anybody graduating with a degree, a specialty in augmented reality.
Yeah, an engineer or a designer or developer. Yeah. No, it's a village, as Dexter described earlier. It's a village, the team is.
Some of the technical schools like Virginia Tech and Georgia Tech, MIT, some of those highly technical schools are teaching augmented reality maybe as a course level work.
That makes sense. It's all about customization.
Yeah.
Yeah. So I think we have time probably for one or two more questions. And one question is kind of changing gears a little bit, is how critical is spatial location and accurate GPS when using AR in the field?
Well, we don't use GPS. We could use GPS, but it's not very accurate. So we use other means to accurately locate, and we're experimenting and researching with even newer technologies to allow us to locate more accurately. We use an index or targeting system for our location. which requires a kind of a fiducial marker to tell us where we are in three-dimensional space, and then the augmentation is then overlaid over the reality. We are working with some technology that will allow us to extend that range and get that range more accurate. And over time, what's happened is the devices and the cameras within the devices and the algorithms required to drive all of that have allowed the accuracy to get better and better and better and better. And it's like there seems to be an incremental improvement about every 6 months.
So the very last question is, what has been your experience with construction companies in reference to design data and stakeholders as they are implementing changes such as AR in their processes?
I think I understand the question. Is it about design changes, you think, or?
Yes. Mm-hmm.
You think
the
it's about
process
design changes?
That as it relates to the use of different technologies.
Yeah, we have a, hopefully this is going to answer the question. If not, let me know. There's a process called dynamic content. It allows us to create applications that when there's an engineering change, the data can be swapped out. So you can take the, let's just say there was a section of a large fabrication and something changed in the piping, and they want to swap, they can then swap that information out for the old part of that module and get the new data so that they have the most up-to-date content, 3D content that they need. Not sure that's answering the question, but I think that's something relevant and something that's important to your listeners.
Definitely. Well, I would like to thank you both, John and Dexter, for coming on, sharing details about AR and VR, and giving us some insights as to how we might have the competitive edge in the future. I would like to invite everybody to save the date for September 19th through the 21st in New Orleans. You can meet John and Dexter in person at the FIATEC Leadership Forum event. So stay tuned. You're welcome to get more information and to revisit this video on the FIATEC YouTube channel. We will have more events like this in the future, so thank you so much for joining us. We appreciate everybody's time. Have a wonderful day.